So good day, thanks for joining me. This is Adobe Fikemba, and I told you in this channel I'm going to teach you physics, chemistry, biology. We just learned biology. Now we're going to be looking at physics. Okay, are you ready? Let's go. Now in physics, we've been discussing dimensional homogeneity, and we are going to I was doing some calculation on how to apply dimensional homogeneity. So we are going to continue from where we stopped, okay? So watch the previous video that taught this physics now. Physics. So watch the previous video that talked about dimensional homogeneity and the example we gave. And in that example, I think I remember we're talking about if the period of oscillation, I want to continue the solving so that I can more examples. If the period of oscillation of a simple pendulum is related to the mass, to the length of the thread, and to the acceleration due to gravity, they give us a relationship with that. T equals what? I think they gave K M raised to power X, L raised to power Y, and G raised to power Z. I think I remember they gave us something like this. And then they said we should find X, Y, and Z. And see if we can use it to generate a formula as the case may be. So, and then we moved on to say, okay, anywhere we see mass, this is mass. You write M, capital letter M. We want to get, we're looking at dimensional homogeneity, capital letter M for the mass, and for the length, L, small letter L, capital letter L. And from this acceleration due to gravity, G, will be what? LT minus 2. Go and watch the previous video about dimension. So all these things I'm writing here represent their dimension. So what do we do now? The next thing we need to do is to substitute this dimension into the what? The related equation. So we'll now have T. I'll solve it in the previous video, but there's somewhere I'm going to. That's why I'm doing this. Is equals to K. Now substitute this M for this dimension of mass, M raised to power X, and then L, capital letter L raised to power Y, and then G, you put LT, you have to bracket it, okay? LT is minus 2, then bracket and put Z. The reason why is because since these two are together, okay, this Z will affect both dimensions. So you have to bracket it. You cannot just go and write LT raised to power minus 2Z, meaning nothing is affecting this. That will be wrong. Your answer will be wrong. So that's why we have to bracket this in this case. So what do we do next? T will now be equals to, we have to rearrange these dimensions, connect the terms. So T will be equals to K, M raised to power what? X, L raised to power Y. Bring it out. This will turn to L raised to power Z. You can put dot, 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 representing multiplication. Okay, in this case, Z and T raised to power minus 2Z. Now, having done this now, we've been able to simplify, that's the term, simplify this dimension. Now, let us make this dimension to become one at a time, because we have two lengths here we cannot achieve, and they have different powers. Now, you need some level of mathematics in physics. In fact, a lot of level of understanding in mathematics. Now, we're going to take a law from mathematics. According to the law of indices, if you remember, if they have this base, the bases are the same. And when the bases are the same, and you are multiplying them, it means you have to sum or add the powers. Are you with me? So what that means now, it will now be T will be equals to K, M, raised to power X, L, can you see it now? Raised to power Y plus Z. Do you understand it now? Since the bases are the same, so for you to make the base one or single or to stand alone, since they have the similar base, you must add their powers. Then dot T raised to power minus 2Z. With this now, we've been able to do what? With this, we've been able to get them as mass, length, and time. Okay? So what do we do now? What to do now is to do what? Is to begin to equate them, okay? But let me tell you something here now. If you watch, in this case, they say we should look for S, Y, and Z. Now, if you watch, it is only T, period, that we have here, that is equivalent to this. I want you to put this in your mind. Since you have mass here, we have length here. So we also have dimension m and l raised to power t. But in this case, this dimension here will be m raised to power 0, and t is raised to power 1. Do you know why I had to do it that way? So that it can give me the opportunity to do what? Because we said that if we have dimension of A is equals to B, okay, then it means that the dimension of A must be equals to what? The dimension of B. And we also said something again, if you remember. If A is equals to BC, then it simply means that the dimension of A must be equal to the dimension of, must be equal to the product of the dimension of B and the dimension of C. And that's what we are having here. So what do we do now? Go and watch the previous video. You will understand where I'm coming from. Now, what do we do now? The reason why I have to raise this m raised to power 0 is so that this dimension must also be equal to this dimension here. But you have to raise it to the power of 0 so that it will be 1 at the end of the day. M raised to power 0 is 1. Okay? L raised to power 0 is what? 1. And t raised to power 1 is t. So 1 times 1 is 1. 1 times t will still give you back this t. So we are on track. Indeed, I want you to understand. So I will clean this now. We'll still use it. So now, you will now begin to bring them out now. Bring it out now. This dimension must be equal to this dimension. So what do you have? T raised to power 1 must be equal to this dimension, t raised to power minus 2z. And in this case, once the bases are the same, what do? You will cancel the base out so that the power will stand. So 1 equals minus 2z. So what's your answer? Z will now be equals to minus 1 over 2. Hold that one. Let it be there waiting. Let's look at the next one now. Now, the next one is we've done T. Let's do for L. Don't forget what I did here earlier on. So that will now be L raised to power 0 will be equals to L raised to power Y plus Z. Don't forget anything raised to power 0 is 1. 1 times this T will still give you back this equation. So having done this, this will cancel. Don't forget that we have 0 is equals to Y plus Z. What did we get as Z initially? Minus 1 over 2. Therefore, 0 will be equals to Y minus 1 over 2. Yes, you'll be asking, there is plus here. Plus times minus will still give you minus. You cannot see it too. So in this case, let's do for the length. So it will be L raised to power 0 will be equals to what? L raised to power Y plus Z. And I told you, once the bases are the same in this case, you cancel it out. What do you have? 0 equals Y plus Z. What do we get as our Z? Our Z is minus 1 over 2. So anywhere I see Z, I'll put minus 1 over 2. So it will be 0 equals to Y minus 1 over 2. Y minus plus times minus is still minus. So Y minus 1 over 2. So if you bring this here, it will be Y will now be equals to 1 over 2. So Y is 1 over 2, Z is minus 1 over 2. Now let's go straight for M now, the next one. This K is constant. So since we've done L raised to power 0, I will do M raised to power 0. So it will be M raised to power 0 equals to what other dimension carries M? Look at it here. It will now be M raised to power X. So therefore, cancel M. What's your X? 0. Can you see that now? So write it. We've gotten the value of X to be what? 0. Y to be what? Y to be what? 1 over 2. And Z to be minus 1 over 2. Do you understand that? Very good. Now let's move on to the next now. You see this thing now? We will now take these answers and replace it back into the what? Into the equation that was given to us, the relationship. To understand, keep watching the video over and over, you will get it. We are dealing with dimensional homogeneity. Now, when you've done that, T will now be equals to K. Are you seeing this now? Anywhere I see this M, I will X, I will replace it to 0. M raised to power what? 0. Are you with me? L raised to power, what is this Y? 1 over 2, put 1 over 2. And G raised to power Z. What's G? Minus 1 over 2. So I will just put minus 1 over 2. Are you seeing that now? Now, M raised to power 0 is already 1. So you have T equals K. Are you with me? L 1 over 2. G minus 1 over 2. Do you know that this thing, now this expression is the same thing as saying T will be equals to K, L raised to power 1 over 2 times 1 over G raised to power 1 over 2. Do you have that? Because of this minus sign. Are you seeing it now? So what do we have now? what you have now will now be T equals to K. Okay? Now, you now see K will be the same as saying L 1 over 2 over G 1 over 2. What is common in power is 1 over 2, 1 over 2. So it's the same thing as saying, T is equals to K L over G. Put it in bracket and put 1 over 2. Do you see it now? Because the 1 over 2 is common. Whatever, this bracket you put now is affecting up and down. It's not only this. So since both of them are having a common power, are you with me? So it's the same thing as saying T is equals to, if you want to copy short principle, this thing now means that it's the same thing as saying K will be square root of L over G. Do you agree with me? Because this 2 represent the square root. Why, when you draw this now, represent the 1. Can you see it now? This is like swap formation. Now, when you are doing this now, L over G, this square root is what we've gotten here now from these 2. Why the 1 comes here as raised to power? As if we have 3 here, 3 over 2. Here we'll have written it as 3. Do you understand it now? But because it is 1, that's why you have it as 1. And anything raised to power 1 is still that thing. So you now have T is equals to K square root of L over G. But remember, according to calculation, K is equals to 2 pi. This is not where I'll start deriving anything. K is equals to 2 pi. Therefore, the period, okay, in a simple pendulum will be equals to what? 2 pi square root of L over G. Go and confirm this formula. So with this now, you can see, when I tell you that dimensional homogeneity is used to do what? To test the validity of any formula in physics. The validity of formula in physics is anchored on dimensional homogeneity. You can see how we've been able to calculate the values of x, y, z and use it to follow the relationship to get this formula. Are you seeing it now? So let's look at another one. Let's look at another example. If a body moves in the air, okay? I'm cleaning already, okay? Because I want to do another one. If a body moves in the air, let's say a body is released in the air, and this body experiences a retarding force, okay? A retarding force, a resistance in the air, and the relationship is given as, let's say, F is equals to K. Let's say it's given as F equals to K A rho X. Then I say, let's calculate S. Do you understand what I'm saying now? Okay, when this now is your area, when this is your area, this guy is density. Density. And this guy is your what? Velocity. So a body that was released in the air, moving at a particular speed, okay, experiences a force, a resistive force, okay, and is given a relationship of F equals K A rho V raised to power X. They now say, what is the value of X? And they now told us that if A is area, this is rho, representing density, and this V is velocity. Calculate the value of S. This is force. Let's go. Let's go. And then after this, I'll give you an assignment. And I know you can do it. I believe you. I believe you. If you follow this principle, this method, you can get it. If you believe me, say, I believe. Let's move on. Write it on the comment section. Okay, so let's go. Now, remember, I told you force is equals to kilogram meter per second square. Take note, oh, this thing is very important. We know force is Newton. Okay? The SI unit of force is Newton. And Newton is broken down as kilogram meter per second square. I beg in the name of God, for you to be able to solve questions like this, you must know this unit, both derived and their fundamental units. Okay, now that's force. The next one is area. What did I tell you is area? A will be what? Meter square. Is that true? Length times breadth now. You understand? M square, meter square. The next one is what? Density, mass over volume. Rho. What's density? Mass over what? Volume. Which is what? Kilogram. Which is what? Kilogram per meter cube. Meter cube. Length times breadth times height. Volume. Understand this, I beg you. The next one is velocity. What's velocity? Displacement over time. Is that not so? which will be what? Meter per second. This is the displacement, okay, over time. Now, having written all these things, you will now derive the dimension of all these things you've written. So for force now, kilogram meter per second. Kilogram is mass. Come here and write it, which is M, capital letter M. Can you see it? Good. What is meter? L. We are doing for force. This one is time. T. Whatever power you see there, put it there. Don't worry. Raised to power minus 2. The next one is meter square, which will be equals to N raised to power 2. Are you following what I'm doing? If you are following what I'm doing, say copy that, sir. Write copy on the comment section. The next one now is what? Density, kilogram per meter cube, which will be equals to, what will be the dimension? Kilogram represent mass. We now write capital letter N. What is the meter? L raised to power minus 3. Very good. What is velocity? Meter L time T raised to power minus 1. Very, very easy if you follow the principle. Do you understand what I'm saying? What I'm saying now? So having done this now, we will now replace this dimension in the given equation. I will now replace the what? The dimension in the given equation. Please, I would like to clean. Okay? So follow me. Let me clean this part, just this side. I will leave the dimension. You can watch the video over and over again. Now, put all these things you've gotten. What is force? Kilogram meter per square. I think it's this one. So you write it force now. Anywhere you see force, you write ML T raised to power minus 2 will be equal to the K is constant. Just put your K. What's A? What's A? Area. Look at it. L2 raised to power 2. What's density? ML minus 3. Put dots here. ML minus 3. You can still put times if you like. No problem. What is velocity? Now look at this velocity. Raised to power x is here. You now put times L raised to power t minus 1. In brackets, you put your x. Can you see it now? Because this is velocity. In bracket, you put your x. Why? Because this x will affect both whatsoever. Are you with me? So what does that mean now? What it now means is that you will now make sure you have all the dimensions in one form, in one direction. So what do we have? What's m? So you have m, l, raised to power t minus 2 will be equals to what? K. Now you have l raised to power 2, okay, times m, l raised to power minus 3. Bring it out. This will become times l raised to power x and t raised to power minus what? X. 1 times x will give you x. Do you understand? Now, having done that, what do we do next? You will now come, you will now say that we want to make this, we want to make, what's it called? Okay, thank you. So now looking at this now, you can observe that you have MLT raised to power minus 2, K L raised to power 2, ML raised to power minus 3 times L raised to this X affecting this L and T raised to power minus X. So what do you do? Now let me tell you something. I don't want us to waste time. Okay? Now they say what's the value of X? What's the value of X? In this case, let me clean this one out. What is the value of what? Of X. Now, look at this dimension here and look at this dimension. You know, we say if dimension of A is equals to this, so therefore A must be equals to B. So look at this T now, bring this T out. You have T raised to power minus 2 to be equals to, look at this T raised to power minus X. Cancel, cancel. What is minus divided by minus? That's it. So X will be 2. Your answer is 2. Can you see it now? Let me do something else, okay? I want to try something else to see. Okay, now this is 2. We've gotten our X to be 2. Now, because you might ask a question, and I know the question you might ask. You might say, sir, but we have X in L. But why did you just go directly to do it from T? The reason is because this T is just 1 here. It's equal to this T here. It's direct. Just like I told you, dimension of A must be equal to this dimension. So now, let's look at this now. We've gotten X to be 2. I want to do something. Now, let me target. You know, this L is the same thing as raised to power 1. Do you agree with me? Do you agree? Good. So, the implication now will now be, bring this L out now. Are you with me? Do you know the reason why we're not dealing with mass? Because the power that we are looking for is not raised in mass. So there's no need to look for mass. So because there's L raised to power X, that's why I want to try something with this. So let's go. We have L. This L is the same thing as saying L raised to power what? 1. Which will be equals to, now work with only all the L's. They must be equal with this dimension here. Not with this or this. So this one is L raised to power 2. Are you with me? And this one is what? What's this one? This is, you can see, if the answer is wrong, this will tell us if that 2 is correct. This can be like a check. L raised to power 2. What's this one? L raised to power minus 3. Another L raised to power X. Follow me, oh. Follow me. Now, what does that mean now? It means L raised to power 1 will be equals to L raised to power 2. What did I tell you about when the bases are the same? When the bases are the same, you know this X is taking what? What's this X? This X is, yes, plus. When the bases are the same, you sum the powers. Is that not what I told you? So you now have 2 plus bracket minus what? 3 plus X. Are you seeing it now? Cancel this L. Cancel this L. So you have 1 is equals to plus times minus is minus. So you have 2 minus what? 2 minus 3 plus X. Are you following me? Now what do you have? 1. Can you see it? No. So, but you can see this one. Yes, you can see it. You can see 1. Yes, you can see that one. Equals to 2 minus 3. Yes. Plus X. You can see that. Let me come here now and bring this up. So having seen this now, you now say 1 will be equals to 2 minus 3 will give you what? Minus 1. 2 minus 3 will give you what? Minus 1 plus X. Now let us collect like term. When we collect like term, we print this minus 1 here, it turns to plus. Is that not so? You can see. Oh, I love, see. When you follow the principle, you become principal over physics. Now what do? You come here, X will now be equals to this 1 plus 1. X is equals to 2. Do you see it now? Which means this is a confirmation that this thing we calculated as X to be 2 in the previous one is the same thing we got as X to be 2 here. Is correct. I'd like you to type correct in the comment section. See you in the next video. If you're not following me, please do follow me so you can get video. I will make this subject simple for you by the grace of God and help you to get A1 in all these subjects. This is one thing I was not opportune to get in my time. It is what provoked me to this glory, to knowing all these subjects. I'm telling you. Follow me. You won't regret it. God bless you. See you in the next video. Chemistry. Thank you.